So this is actually the from the point of electrical charge, we have some summaries that we all know from our basic concept of physics, that there is a property of matter called electrical charge. So electrical charge is a property of matter, and the SI unit for electrical charge is coulomb. And charge can be positive, like electrons, or positive. So you should know that the charges we are talking about, it can be positive and it can be negative. And in matter, the positive charge are stored in one place in the nuclei. So matter is negatively charged when extra electrons are added and positively charged when electrons are removed. So you should understand that, because in the atom or in a matter, we all have this basic knowledge that matter is made up of an atom. An atom is what makes matter. And this matter is having some, or the atom that we are talking about is having a structure. And the structure of this atom is actually made up of, let's look at it. Let's look at the structure of the atom. So in the structure of the atom, we have something like this. We have a cycle, and then the first cycle here is called a shell. This one is called a shell. And of course, we have nucleus. This is nucleus. So the protons is found in the nucleus. So we have protons here in the nucleus. It is located in the nucleus. So that is why the protons, or the positive charge, is stocked in one place, which is the nuclei. And then the matter is negatively charged. So when an electron is added, like for example, when we have, let's say, sodium, and then we have chlorine. So when electron is being added, or extra electron is added, then the matter will now become negative charge. So it will be negative. Like chloride here is negative because an electron is added. And then when electron is being removed, like in the case of sodium, then it will be positive. And that is how it is. So when you have like charges, like for example, positive and positive charge, positive and positive, they will repel. And when you have unlike charges like positive and negative, they will attract. And charges travel in conductors, not insulators. So usually these charges, they travel in the conductor. That is the material that allow electrical charges to flow. So because charges are only traveling in a conductor, so that is why it is only conductors that produce electricity. Like for example, most of the electric wire we have is because they are conductors. They allow electrons to flow through them with low resistance. Conductors generally have low resistance, and that is why they allow the flow of electrons to pass through them very well, and that is why they are called conductors. But in the case of insulators, they have very high resistance, they have very high resistance, and that is why the electric charges cannot pass through them, and that is why they are considered as an insulator. And then the next thing is also the force of attraction or repulsion is approximately 1 all over r square. Force of attraction or repulsion is approximately 1 all over r square, and we are going to look at that too. Okay. So now we are going to look at the charge. Charge is quantized, that is Q. Q stands for charge. So multiple of an electrical charge is E. So we have the charge, the standard charge of an electron. So the charge of an electron is 1.6 times 10 to the power of 9 coulombs. So you should know this. And remember, as we said, in an electrical or in an atom, we have electrons, we have protons and neutrons, and we also have positron. So electrons is usually represented as minus E, Then proton is plus E, then neutron is 0, and then positron is plus E, and they have their masses. And the mass of electron is 1, and the mass of proton is 1836, and the mass of neutron is this, and they also have diameter. So the diameter of electron is 0, and the diameter of positron is also 0, while the diameter of protons and neutrons is 10 power minus 15 meter. Okay, so this means that these three fundamental particles, you should all put them at the back of your mind. Please, ladies and gentlemen, to understand that these fundamental particles of an atoms, they have charges, they have their masses, and they have diameter. But in the case of electrons and positron, the diameter is 0. But for the protons and neutrons, their diameter is 10 power minus 15 meter. And these diameters are also important in terms of their attraction because we have radius. So when we look at the Coulomb's law, we'll look at how these diameter are related with the radius. Of course, from the basic of our knowledge in mathematics, we know that diameter, when you have diameter, radius is equal to diameter divided by 2. So it means that there is a relationship. So since we have this, now of course from the force of attraction that we said is inversely proportional to 1 all over r square. So it means that the diameter and the force of attraction, there is a relationship. The diameter of protons and neutrons have the relationship with the force of repulsion or attraction. So protons and neutrons are made up of quarks whose charge is quantized in multiples of electrons divided by 3. So quarks cannot be isolated. Okay. Hello, can you hear me?